Hello, everybody, and welcome back to day 5, the final day of Python WebConf 2021. It's sad that it's the final day, but luckily we have some awesome speakers today. One of those being Aly. Aly has been super awesome just in helping not only with the Python WebConf and being a part of this over the years, but also been a great asset for us as we organize IndiePy. Aly, I know you can probably speak more on kind of the things you do up in Chicago, but Aly is one of the co-organizers up there for Chippy, the Chicago Python user group, and he's just been awesome. So super excited to have you here, Aly.
Okay, awesome. Thanks so much, Josh. Really appreciate those kind words. It's always fun doing things with IndiePy. You guys have a great community out there. All right, let me share my screen. All right, should be good to go.
Looks good.
So, perfect, thank you. So I wanted to start by thanking the organizers of the Python Web Conference for putting on this conference and inviting me to speak. Huge thanks to everybody out there watching. Let's just have some fun. My name is Aly Sivji. You can find me on Twitter. I am at Sivjas. I live in Chicago and I work as a senior backend engineer at Noteworth. Noteworth is a seed stage startup. We're building a digital medicine platform that care providers, specifically nurses, can use to track and monitor patients. We're doing a lot of things with Python, with Django, and with serverless technologies. We're always looking for talented product and engineering folks. If you see a job posting on our website, please reach out. We're a remote first company and we have employees all over the world. As Josh mentioned, I'm also one of the organizers of the Chicago Python users group. We call ourselves Chippy. We're one of the largest Python user groups in the world. We have around 6,000 members. Normally, I'd like to invite you all to come out to Chicago and attend an in-person Chippy event, but it doesn't feel like that's going to be happening for quite a while. Fortunately, we've been able to transition our in-person calendar into a virtual event schedule. There's a lot more information on our website. All right, let's get started. I'm a huge fan of AWS managed services. With just a few clicks, we can spin up over 200 different cloud services that do anything from saving documents in a bucket, that's S3, to developing voice-enabled applications, that's Amazon Alexa. We can use a language like Python to glue together a bunch of different API calls from AWS, and we can pretty much solve any kind of problem we can think of. And this is fantastic. By leveraging managed services and writing just a little bit of code, we can deliver features really quickly. While I'm totally okay with the vendor lock-in that comes from depending on AWS, since it allows us to deliver products faster, there are some downsides to working with cloud services. Working on the cloud costs money. If engineers are going to be using cloud resources for development and for testing workflows, our cloud costs are going to get out of hand. And this is a problem for management. A problem for developers is that when we're developing on the cloud, it usually means we're making a bunch of API calls. And then we have to go out and write tests against these APIs. We're going to have to mock or stub every single API call. And that's just going to get really complex. Fortunately for us, there's an open source tool called Localstack that solves this problem for us. With Localstack, we can develop and test cloud applications offline. In this talk, we're going to dive deep into Localstack, and we're going to look at different development workflows that can improve application development. While all my examples are in Python, Localstack is a language agnostic tool, and we can use this tool pretty much anywhere. So you're probably wondering, what is Localstack? Localstack is a tool that replicates the AWS cloud in your local environment. Basically, it's a Docker container that contains an AWS-like environment for development and for testing. The community edition of Localstack supports a variety of AWS resources. While this is a far cry from the 200 plus services that are actually on AWS, it's got the main ones that we can use to write and test serverless applications. We have API Gateway, CloudFormation. We have Dynamo, both the database as well as DB streams. There's Elasticsearch, IAM, Kinesis, Lambda, S3, SNS, SQS. This is a diagram I pulled from the Localstack website. So on the left, we see that a developer can spin up a local stack container in their local development environment and write code against AWS-like resources. And in the middle, that's our continuous integration environment. We could spin up a local stack container to run our tests against. Now, when we deploy to AWS, we can have confidence that our application works exactly as it's supposed to. I think the best way to see the benefits of local stack is to jump into the terminal and see it in action. So you can go to the localstack GitHub page, check out the README. Note there is a PyPI package we can use to interact with localstack, but in my opinion, this is sort of just an unnecessary dependency, especially since we can just use Docker directly. So from their README page, it says that we can use Docker directly and use the following commands to get started with localstack. So it's a Docker run, remove the container when it's stopped, connect a couple of ports, and then the image name is localstack in the localstack repository. And this is going to run a throwaway container without any external volumes, which makes sense. We didn't mount any volumes. And if we want to start a subset of services, we can use an environment variable. You know what? We'll come back to that in a little bit. So let's just go into the terminal and get started. So this is a VS Code instance. I also just have my terminal in here. It's integrated. I'm going to go into my demo directory. There we go. And let's just do a Docker PS to make sure that no containers are running. It looks good. And also, we'll just make sure that, actually, you know what, we'll start a Docker container now. So we'll do a Docker run -rm -p to connect the ports. We only actually just need to connect one port, which is 4566. That's the port that localstack is going to be exposed on. And then we can just do localstack. And there he goes. It starts the container, so you can see it's spawning all of these things. And it's starting all of our services. Looks good. Let's just wait till we get the ready. And now we are ready to go. So I'm just going to start up another terminal. And here we can use the AWS CLI to interact with localstack. So we can say AWS, use the -- endpoint URL and point to our localstack instance. So it's 4566. And then we want to see what's in S3. So let's just do an S3 ls. Okay, it doesn't look like we have any buckets there. So let's go ahead and create one. So we'll do an MB, which is make bucket. I'm going to call this bucket demo bucket. And now when we do an ls, we can see that we do have the demo bucket there. Okay, but before I go on, I want to introduce this tool called AWS Local. This was a utility created by the folks over at Localstack to save us some typing. So we can do an AWS Local S3 ls and see exactly the same thing. So it just takes this AWS Local and it aliases it to this particular endpoint URL. So now let's go ahead and create a file. So we'll just go into our demo directory. So there's already a file there. So let's just create another one. So we'll go echo hello Python web conference. And I'm going to pipe this into new greeting.txt. Let's just do a cat to make sure that things are there as expected. Looks good. And now let's upload this file to our local stack. So we'll do an AWS local S3. It's going to be a CP. So it should be new greeting. And we want to put it to our S3 demo bucket. And let's also call this new greeting.txt. And it says it's uploaded. So we can do an AWS local S3 ls. I think you can just do demo bucket. Cool, the file is there. So we're going to take this file, copy it to our local directory, and just make sure that it's exactly the file that we uploaded. So we can do that by doing the other copy, the copy going the other way. So we'll do an AWS local S3, copy this file path, and call it downloaded new greeting.txt. What's going on here? Oh, I forgot the CP. There you go. And there it is. So now we can take a look at the downloaded new greeting, and it says hello Python webconf, which is exactly what we put in to the file we uploaded. And so that's just S3. We're really scratching the surface of Localstack. So I'm just going to close down my container. Let's close this process and then do a docker ps, copy this container name and do a docker stop the container. So next, let's talk about how we can configure Localstack. Most of Localstack configuration is done using environment variables. There are a ton of configuration options. Really recommend y'all go and skim the README to find out what's available. But I did want to highlight a few options that everybody should be familiar with. So the first option is edge port, and this is the port that Localstack is listening for AWS API responses. As I mentioned, the default one is 4566. If we're, say, running Localstack in a bunch of our different projects, it might make sense to change this port for each of our projects. We can use the services variable to provide a list of services that we want to start when Localstack first launches. And these service names, they correspond to the names available in the AWS CLI. And for example, if you just wanted to start Kinesis, Lambda, and SQS, we can say services equals Kinesis, Lambda, SQS, and it's only going to start those three services. We can also set some AWS settings. So if you want to start Localstack in a specific region, you can set this setting. The default is US East 1. And if you're ever going to be using the AWS SDKs inside of the Localstack container, say you want to use Boto3 to start up some resources at runtime, we can set the the AWS environment variables that are used by all the SDKs. So that's going to be the default region, the access key ID, and the secret access key. If you're developing and testing inside of a container, you might need to modify some hostname settings to make sure that traffic is directed to the correct Localstack service. We're also able to use data dir to specify a directory inside of a container where data is stored. And the services that are currently supported for data persistence are Kinesis, DynamoDB, Elasticsearch, S3, Secrets Manager, SSM, SQS, and SNS. And if you want to keep this data persistent across sessions, we can add a Docker volume mount to make sure that a local directory is mounted to this data directory. And finally, we can use the init scripts path to run a set of scripts from a volume mount when a container is first launched. And this is really handy when we want to create resources that are required by our application. Putting all of this together gives us the following Docker run command to start up a Localstack instance. But before we run this particular command, let's convert it into a Docker Compose file to make sure our configuration is self-documenting and it's reproducible. And now we're going to walk through the Localstack configuration that we're going to be using for upcoming workflows. So go back in here. We're just going to open this Docker Compose. It's just version 3.6. We'll come back to this volume up here. Creating one service, calling it Localstack. This is the latest Localstack image that I found as of last week. Here we're going to be setting some environment variables, connecting our ports. Here I'm going to be mounting a directory called onStart to my initial scripts path. And I also have a way to mount my data directory using a Docker volume right up here. I don't really like having my data persistent across sessions, which is why I normally leave this commented out. So now we can just go ahead and start. Actually, we'll show you one more thing. I also have a makefile. I like makefiles as a way to wrap commands just so I can remember them like a few weeks later when I come back to the project. So I've just wrapped Docker Compose commands with make up and down. So going back into the terminal, we can do a make up and bring up our Localstack instance. And while that's going on, let's talk a little bit about our first workflow. So in our initial demo, we did it with the AWS so AWS CLI. This time we're going to be interacting with S3 using Boto3, which is the AWS SDK for Python. So to start, if you're not familiar with S3, it's a service that we can use to store files inside of the cloud. And we'll just go through this example just to make things a little bit more concrete. So that service should be up. And here is the first script. So I'm just importing Boto3. I created a function called upload file to S3. You pass in a file name, a bucket. There's also a couple of optional parameters, one for the object name if you want to set that. And if you want to use Localstack, you can set this to true. Otherwise, it's going to use AWS natively. We're going to create our instance of our Boto3 client, and then just use that to upload a file. So let's just go back to the terminal and see what's going on. So we'll do an AWS local S3 LS. We see that we have the example bucket. You know what? I didn't go show you what files are created at start time. So let's do that right now. So as I mentioned, when we're creating files at start, it loads a bunch of scripts from a folder you specify. So it's going to run all the .sh scripts. So here I just have an sh script that's executable that is going to create a DynamoDB table, create an S3 bucket, and create an SQS queue. So looking at the S3 bucket, we're going to be creating a bucket called example bucket using Boto3. Pretty standard stuff that I pulled straight from the Boto3 documentation. And now let's open up IPython and run that script to see if we can actually upload a file to our local stack using Boto3. So just make sure that we're in the right folder. Very slow one. Okay. Awesome. So we'll run our main script. So that's going to do that with IPython. Let's create a file here that we want to upload. Let's call this sample file.txt. And we'll just print hello world here. And now we can use that that Python function we wrote to upload a file to Localstack. And so I just created this file called sample file.txt. I want to upload it to bucket equals example bucket. And then I want to use Localstack. And I got a response that it was true. So it looks like it succeeded. So let's go back out to the terminal and make sure it actually did succeed. So that'd be an AWS local S3 LS. And then we'll do an example bucket. I'm still in the terminal. There we go. Okay. Now we're in the terminal. Now let's run that. And there we go. We see that sample file. I'm not going to download this since we just did that earlier, but we sort of see that it does work exactly as it does inside of the CLI. So how would this be useful as a web developer? Well, you can take advantage of Localstack by maybe if you store your static files and your media files in S3 and serve them over a CDN, we can add Localstack to our development workflows so we're testing against actual production-like resources. I did include an example for Flask where I create a specific client for S3 that wraps Boto3, and then I use this client for S3 interaction. And depending on the environment we're in, it's going to be either development, staging, production, or local. We can use either S3 that's on Amazon, or we can use the Localstack S3. I also included a link on how to configure Django storages to switch between Localstack and S3 for your different environments. And if you're actually using an object store with an API that's compatible with S3, check out min.io. Localstack is a pretty heavy dependency. Min.io focuses on doing one thing and doing it well, which is being an S3 clone. And if you're not using AWS and you want to do a flow where you're uploading your static files and media files to an S3-like store, check out min.io. It's a lot better for that particular use case. For our second workflow, we're going to be talking about how we can work with DynamoDB. DynamoDB is a key value store that's built specifically for serverless workflows. A DynamoDB table consists of a unique key and a set of values. And this key, it could be a single key, which we call a hash key, or it could be a composite key, which would be a hash key and a range key. And then once we have the key, we can look up our item, which is going to be our set of values. And because we have this key value relationship, our database is going to have constant access time, regardless of how much data we have in our system. And just a caveat on that, that's only really true if we've modeled our access patterns properly. I don't really want to get into too many details about how to model data in DynamoDB, since that's like a talk all to itself, but I did include links for folks to dive into later. I also want to make folks aware of a few different libraries and tools they can use. One is called DynamoDB, and you can think of that as an ORM for DynamoDB. And there are a couple of Dynamo GUI tools. I really like Dynamodb Admin, but if you want something a little bit more heavyweight, Amazon makes one called NoSQL Workbench. So in this particular workflow, I'm going to demonstrate how we can use DynamoDB to interact with Localstack. And if you're familiar with Django or with SQL Alchemy, a lot of this should look really familiar. We have a model that's going to inherit from the Dynamo base model. We're going to specify some model attributes. Notice that email has the attribute hash key equals true. This means that email is going to be unique inside of this user table. And here we also have to specify some metadata that corresponds to the environment that we're running. And here we're just going to specify that this is our Localstack endpoint and set the table name. Let's go back into the terminal and see how to play around with this. And I just want to show you exactly the DynamoDB table that we build at start time. So we're going to be using Boto3 to build a table. It's going to be called a user table, unsurprisingly given the example. And our key schema has email as the hash key, and it's going to be a string type of attribute. And I'm also setting my provision throughput. So I have 5 read capacity units, 5 write capacity units. Just a tip, if you're doing Dynamo in production, start off by doing like on-demand pricing. That way, once you find out how much you use like your write capacity and your read capacity, you can actually start setting that with a value that makes sense. But really, like on-demand is not that much more expensive. So it really saves you time from having to do these kind of calculations yourself. So I recommend you all use that if you're doing this in production. Okay, so let's go to our second workflow. So here's just the models that we just talked about. And I'm going to be loading this into IPython. So let's just go down to the terminal and open up an IPython instance. And here I'm going to be running models.py and loading all of that in. Let's just make sure that it did load. So it looks like that is inside of our Python process. So let's create a new user object. So we're setting their email. So I'll just use my information here, alysivji@gmail.com. I think it was name given. Call that Aly. And name family. And we'll do a user.save. And it looks like things were saved in that table. So what we can do is we can open up another window and start up that DynamoDB admin just to make sure things are in the database. I have to load npm just because I load things lazily to speed up my terminal startup time. So now we'll do a Dynamo endpoint, point to our Localstack instance, which is 4566 port on localhost. And this program is called Dynamodb Admin. So it looks like it is running on this port. So we'll go here and we have a user table and it looks like it has that record that we just created. Let's just make sure that this works. So I'll go back to my original record and I'll say user.email. Let's say my name. So user.name given updated user.save. And go back to our go back to our admin, and it looks like that name was given. So it was actually updating exactly the way we expect things to work. So the example we just went through, we were only really pointing to Localstack. If we wanted to use this model in production, we're going to need to use environment variables to point to different API endpoints. And the main thing I just really want to call out is here, I am setting my Localstack endpoint as a conditional. And then if that conditional is there, I'm going to set the attribute on the host. And this might be a pattern that might be helpful for folks using this in production. This is actually what we do at Noteworth in production. So for our final workflow, let's see how we can use SQS to build asynchronous processing pipelines. So SQS, or Simple Queue Service, is an AWS managed service that enables us to decouple and scale microservices, distributed systems, and serverless applications. SQS is ridiculously cheap, and you get your first million requests for free. And after that, it is 40 cents for every million, which is like absolutely unreal pricing. So the reasons I like SQS are it's fully managed, it's competitively priced. We're also able to integrate with other AWS services. If we want to encrypt our queues, we can easily do that with KMS. We can set up some CloudWatch alarms. That way, if we have too much throughput, we can get some error alerts. We can also use SQS to set up a redrive policy and send messages that don't succeed to a dead letter queue. And best practice, create an alarm on that dead letter queue. If you want to do some auditing, we can use a managed service like CloudTrail. And so the uses of SQS are, it's a message bus between different services or different Lambdas. I included a links to the doc. So if you're using Lambdas, you can trigger on the SQS event type. And we can also use SQS to set up a task queue for like a worker framework like Celery. And I think Celery and SQS is a great way to send messages from serverless apps to Monolith. So this is actually the very high level simplified architecture diagram of a couple of services we have at Noteworth. So we have our monolith, which is Django. We have a few instances of that Django. We have some Celery workers. We have a Celery beat scheduler. And then we have another service, which is just a bunch of Lambdas. And our services, they talk to each other by putting a message on the inbound queue of the other service. So let's go ahead and just take a look at how we can use this workflow to figure out how to send messages. So let's go back to the terminal, get out of this process. So in workflow 3, we have a file called sender. I'll actually show you also how I create these queues since I have not done that yet. So I'm just going to be using Boto3 to create queues, pretty standard to the things that we were doing before. And here I'm just loading Boto3. I have a queue URL. Let's quickly sort of see how we can get that. We can go in AWS local SQS list-queues. And then we can see all of our active queues that are available in that Localstack instance. So this is where I got this queue URL. And then I created a function called send message to queue. We pass in a message, a parameter that's injecting if we're using Localstack, yes or no. If it is Localstack, we'll point to Localstack. Otherwise, we'll use AWS. And then we'll create an instance of a queue and send a message. When we're sending a message using SQS, it's going to be sending it as a string. So we have to do a JSON dump a dump string, to send out our dictionary as a string. So let's go into IPython and send a message to make sure that we're able to do this the way we think we are. Okay, so we're going to just do a run sender.py. Let's create a message. So event type, we'll just call this a ping event. And our event data will be a nested dictionary of so payload and test. Looks good. And now we can call that function that we just loaded, send message to queue, pass in our message, make sure that we're telling then to use Localstack, and it looks good. So how can we find out if this message was actually sent and it's on the queue? We can go back to the terminal and do an AWS local SQS, receive I before E except after C. There we go. And it's a queue URL. And I'm just going to go back to my script and pull that queue URL. And there you go. We can actually see this message body. And it looks like it is like a JSON string. So we can just double check that. So just open up IPython, do an import JSON, JSON dump S, or sorry, JSON load S, since we are loading the string. And it looks like the payload that we had sent a little bit earlier. Can't find it, but we know it's there. All right, cool. I also really wanted to include this other code snippet that, that you can use to send messages to be picked up by Celery workers. So say you're doing like a workflow that you're sending a message from SQS to your monolith, and your monolith only really knows about Celery. We can use this configuration and do an explicit app.sendTask to send a message to our Celery workers using the Celery protocol that these workers actually understand. And as I mentioned, this is sort of how we design our system architecture at Noteworth. If our message is going to a Lambda, it's going to be processed like normal. If our message is going to the monolith and being processed by our Celery worker, we translate it to be in a message format that the Celery worker knows about. I just call that the Celery protocol. And another thing that we do is we use marshmallows to define our communication payloads between our services. And since all of our backend systems are in Python, we're able to define contracts between our services with just pure Python code. So those are all the workflows I really just wanted to cover in depth. But I don't want to make everybody aware of other uses of Localstack. These are ways that I've used Localstack before. If we're running tests against Localstack resources, we can take advantage of PyTest hooks to create AWS resources and then to tear them down before and after each test case is run. We're also able to use Localstack to do an end-to-end deployment, or sorry, end-to-end testing of our serverless applications. So if we have a CloudFormation of, say, something like AWS SAM framework or the serverless framework, or maybe something like Zappa, we can use that CloudFormation, throw it into Localstack and deploy it, and then do an end-to-end test to make sure that information coming out, information going in and information coming out are exactly what you expect them to be. We're also able to use Localstack to validate our infrastructure as code. If we're using something like Terraform or something like CloudFormation, we can spin up resources by pointing to our Localstack and then run some tests to make sure the correct resources with the correct permissions were actually brought up. All right, so let's recap. Localstack is a tool that replicates the AWS cloud inside of our local environment. And since we're developing and testing against resources which act as AWS resources act, we have confidence that our application is going to work as it's supposed to when we deploy from our other environments into our production environment. But replicating our production environment does come with a price. Localstack is a pretty heavy dependency, and using it in all of our tests means that they're going to be a lot slower than if we had used mocks or stubs. Personally, I am not a fan of mocking. I like to set up actual resources that are going to be resources we see in production. We can use Docker to do this, makes it really easy. But this is not a decision that I can make for you. It's a decision that you and your team are going to have to make for yourselves. Here are a list of resources that helped me get started with Localstack. Thanks everybody for your time. And before I go, I do want to give a shout out to the Chicago Python Users Group. I would not be where I am without that fantastic organization. Again, my name is Aly Sivji. Thanks again for your time, and I will take your questions.